Moin! This video is part of the scientific Python programming lecture at the University of Bremen. And in this video we would like to talk about the version control system Git. In an earlier session we already did so, and so now you are already capable to track your project, and basically with the help of Git that makes making commits time to time and track the history of your project development. And in this session and the next one we would like to investigate how Git can help us to coordinate parallel development. So basically, if two different things are developed at the same time, or if multiple developers are working on the same project at the same time. As always, of course, we are doing everything in our Ubuntu environment, right? So basically, you should start your virtual machine in order to be able to follow the exercises. And as always, you can download the slides, which are basically containing the most important things about this lecture from the website of the course. And as I already told you, we will have two different topics covered in this lecture and this session and the next session. And in this session, I would like to start with the one repository multiple branches approach. So what does it mean? If you think about that, it means that one developer is working on a project, and maybe this developer would like to test different features independently from each other. Just think about that. You have a big programming package, and you just have an idea how you can extend it, and then you start basically to implement the implementation of this idea, and then somebody else comes and say, look, what about a completely different idea? Let's try to implement that one. And then, of course, you didn't finish the feature of the first one yet, so it's not something you can add to officially to the project. It's not stable enough, as we usually keep to say. But on the other hand, you would like to try the other idea, and then what can you do? And basically what you have to do is exactly shown on this figure here. So basically, until now, we were always working with a master branch. So basically, that was the development line of our project, and our history was linear. So whenever you had a look, for example, in Git K or QGit on the history of your project, it was a very nice straight history. But it doesn't have to be. So basically, Git is an incredibly, very, very flexible, powerful version control system, and it allows for parallel development. And the parallel development in the language of Git, it's called branches. So if you look at this line here, the original master line, and at a certain commit, when I think the time is ripe to try to test a new feature, instead of just trying to implement this feature on the master branch and maybe checking in some half-baked, not really working versions of the feature yet, I can just basically say, let's make a parallel development, a new branch. I'm just branching off from this point, and I am making commits which are not in the master branch, but in this so-called parallel branch, in this feature branch in that case, if it's about implementing a feature. And when I just do it and implement my feature, and then some other idea comes to my mind, I can just go back to the same commit on the master branch, and from the same commit or from another commit, I can branch off another branch. So basically another parallel development line, and then that would be, for example, the development line, the branch from feature 2, and then I can basically commit my Git commits basically into this parallel branch. And if I think that the feature is mature enough, so let's assume that feature 2 I could finish earlier. That is a quick feature which I managed to do, and I managed to document it. I managed to make the test. So basically, no, it's mature enough to be merged to the master branch. And I already used the word, which is the Git terminology of taking the changes of whatever you did into another branch, usually into the master branch, means it's merging it back. That would mean that basically Git would know that this commit, which we created here, contains all the changes which have been on the master branch until now, but also all the changes which have been done on this feature 2 branch. So basically here you see that the history, if you look at the history of this history of the commit is basically has a split. So basically it is split in two ways if you go back in time, and then you can go this way and this way. And of course in Git this is a directed graph. Basically when you go back in time, whatever you meet are changes which are contained in that version. So basically merging means nothing else, just take all the changes which has been done on the special feature branch and apply those changes here to the version of master here. So basically add all the things which had been done here into this commit into the master branch. And then if later I'm finished with feature 1, so feature 2 had been merged, so basically I'm finished. And if later in time I'm finished with feature 1, what I can do is again merge the branch feature 1 into master. That means I am taking all the changes which I have done in this separate branch, which was nothing to do with master, apart of the fact that it was branched off from master at a certain point. I'm merging it back. That means I'm applying all the changes which were done here to the version on the actual version of master. And this actual version of master to which I'm applying the changes contains already the changes from feature 2, because that has been merged already to master. So basically at this point I will have a commit which contains both the features of the feature 1 branch and the features which were developed in the branch feature 2. And basically that's all about it. So basically what you can do is having parallel development starting at a certain point from a given branch. And if you think you want to put back the achievements in the parallel developments, merge them back to the branch, then you are merging it back. So far the theory. Of course it can happen that the changes you make here are incompatible with the changes you make here. Then at the merge, as we will see in a few minutes, then the merge will raise so-called conflicts. That means it would say there's something that you have made concurring changes, incompatible changes which I cannot resolve. Then you have to resolve it manually. And basically it's usually a very good tactics, and you are supposed to do if you have a larger project, but you can also do it for smaller project. Whenever you are implementing a new feature, you should create a branch, implement your feature, and merge it back. So this branching and merging is a very, very substantial and fundamental part of Git. And basically if you're working with Git on a regular basis, you are always creating branches and merging branches back because it's also very, very simple to do it in Git. Now that's maybe a little bit abstract, so let's have a look how we can do that in practice. And I was basically preparing an exercise, and we will just step by step go through this exercise, and that means we will just create a project with 2 parallel branches and merging it. And if you look at the slide, you will see that on the slides I'm not just giving you here the comments, but I'm also always showing what the graphical Git client, for example Git K, which we are using on that machine, shows you, because that shows you very nice the history of your project. Okay, so I would suggest we just start. So we will just basically open here a window and a command line window, and we will just create a folder which I will call Git demo, and I will just call it, just to be here in sync with the notation here, Git demo, and then we will call it 1, because this will demonstrate the purpose that if you have one repository with multiple branches, and within that we should create the hello directory. That will be our project directory, right? So I'm just creating this directory. I'm just going into this directory, and if you don't know that, this bang dollar means that take the character, take the last parameter of the previous shell line, which would be exactly that directory. So I can immediately change to that directory. It even says that was the command with which was created. And of course, you know, if I want to have a Git project, I'm just saying git init dot. So basically, I make sure that this project can be tracked by Git, and it will be a Python project. And because it's a Python project, I will just edit it in Spider. So basically, let's start Spider3 in the background. And we can just add this directory to the Spider3 as a Spider3 project, and we can work in Spider all the time. Because that also will show you that if you're changing branches, you will see it in a second. Spider is automatically reloading things. Okay, so Spider has roughly started, and I will just open a new project, and I will just take it from an existing directory. I will just choose the location. The location would be my home folder, then git demo 1, and here the hello project, right? So basically it's the hello project, and this is at the moment an empty project, and that's also good. So, and that's it basically. Spider has created it. It's starting Python, no Python is running, and this is my hello project, and there is nothing there. This temp.py is not part of my project. It's something Spider always opens if you open a new project. Okay, and then we are just basically creating a new file. Let's just call it hello.py. Should be not very complicated. I will keep the project incredibly simple because the purpose of the exercise here is to demonstrate basically the capabilities of Git. So we are just creating hello.py, and that's our file. And this hello.py should be super simple. We will just write out the string hello, not very complicated, and I'm just here storing it. Now I'm going back with Alt Tab. I'm going back to the window here. You know Git, you know that here in order to register a file in Git, I have to add it. So I'm just saying git add hello.py, and then I'm with git status, querying the status. You know, we have this alias, is like st we are using for git status, and you see that it already says that okay, there's a new file hello.py, but also there is this .spy project folder, which is just some intermediate or some configuration folder of Spider. And this is definitely something I do not want to track. So basically I will create here a new file, which I will just give the name .git ignore. And you remember in the .git ignore file, we can just collect the things which we want to, which we do not want Git to track. And definitely the spy project directory should be one of those. Okay, and then if we go back, then we make a git status, then the .spy project vanished, fine, but of course .git ignore is there, so I will just git add .git ignore, and this is basically good enough for the first start of my project. So I will just say git commit or check in, which we were abbreviating with CI, and I'm just already giving the message, the log message on the command line, and it will be the initial check-in of the project, right? And basically that's it. I started my project, and we would like to track our project also with a graphical Git GUI to see how the history looks like. And you see that's very simple. We have here a master branch with a single commit, and this the commit has the log message initial check-in. Okay, and now basically we want to go back to the point what we have depicted in the slides here with this branching. So basically we would like to create a feature branch, feature 1, and implement some trivial features. And if you look at here, it's very easy. We will just create the branch which is called cleanup. First, this cleanup means, I mean, we know that if you look at our project is very badly written. Let's say this is a good first guess. You see already here there are some nodes Spider itself makes, and if you would make, of course, a static code analysis, then of course you see that our Bálint score is a nightmare, is -10. So there's definitely, this project is good enough for a cleanup, but this cleanup I would like to make in a parallel branch. I don't want to basically touch master, the main branch so far, because maybe during the cleanup I am breaking things. So I would be cautious. So if somebody wants to have my project, I still will give them the state on master, because that's proven to work. If I run this code, of course, it will print hello, so that the project, I can even test it. But of course, it's let's test whether our project works. It seems to work, so the project is perfect. So basically, if somebody asks for the project, this is the version I want to give. But in the meantime, I would like to also make a cleanup. And this is exactly the point where I would say, okay, for the cleanup, this is a new feature. I'm cleaning up my code. I'm just creating a new branch. First, I'm looking at what branches I have. Master branch is the only one, and this is exactly what we see also here in the, sorry, not in this one, but in this one, in this graphical environment. And now I'm creating a new Git branch, so I will say Git branch, I'm giving a name, and that will be the branch cleanup, right? Okay, and that means I have created this branch, and if I'm making Git branch here, you see that indeed there's a new branch has been created, cleanup. I'm still on the master branch. This star here and the green color indicates that I'm still on the master branch, but at least a branch named cleanup exists. And if I look up here and with F5 just update the tree, then you see that okay, here is cleanup as a branch, as a new name, and this also points to the initial check-in. Of course, I was creating the new branch just now, so the moment the state of this branch is the same as the master branch. And now let's start to change first to change to this branch and make a development on this branch, and that you can say by checkout or git checkout or CO, and you're just specifying the name of the branch. And then it also says, okay, now I switch it to branch cleanup. It says so, and basically you can also check it if you say git branch. You see that now we have still the same two branches, but we are now on the branch cleanup. And if you go to the graphical tool here, then and with F5, then okay, it didn't, and you reload it with Shift F5, reload it, force reload it, and you see that basically now the cleanup branch is bold. So that means we have changed to the cleanup branch. Okay, and now we are just making our development, or feature development, and that means we can just go here and basically the first thing would be just to wrap this thing. We have learned that it's usually, if you have a script, it's a nice thing to wrap it into a routine, which we usually name the main routine, and this main routine will contain print hello, and then here in order to make sure that it's executed, if this thing is executed as a script, we will say if name is equal main, then just call the main routine. So that would be, for example, one possible step in order to clean up this code. Here it says that we have, okay, blank line contains here a white space. That's not the case anymore. Now it looks somewhat better. Of course, the project is still undocumented, but as I said, at least we made some improvement already. And let's say, okay, this improvement is already big enough in this toy project, at least, to be checked in Git. So basically I'm just changing to the Git window on the command line window. I'm just asking Git status, and you see, okay, hello.py has been modified. I'm just adding everything which has been modified to the stage. You can do that with the -u option. Everything which has been touched and modified is put to the stage. And if you say git status changes to be committed, then you see this modified hello.py would be committed. So let's commit it with git CI, with abbreviation git CI. And then basically what did I do? I was just wrapping wrap script into main routine, for example. So I do so, and I have checked it in, and then if I look on the git log, I see that that's the case. It has been checked in. If you use git slog instead, you see basically here the same thing in a little bit nicer way. And if you here reload now in the Git client, then you see that basically now the master, the pointer which points where which commit is the so-called head of the master branch, which means the last commit on that branch is still initial checking, but the last commit on the cleanup branch is now this new one. So basically these branches are nothing else, just pointers to certain commits. So basically it's nothing complicated, nothing mysterious. They are simple names which are associated with a given commit. And that concept you already learned about with the tags. We have learned that you can tag a project which gives a name to a certain commit. Branches are basically also tagged commits, with the difference that basically those names are automatically propagated. The normal tags are fixed, so that if you ever give a tag name to a commit, it stays there as long as you don't delete it. But with branches, it's a little bit different. It's a name which points to a commit, but this name is moved to the next commit if you are making basically a commit to a certain development line. Then basically it shows to the head of a given branch, we say in Git language. So basically it shows to a commit, and if you are adding commit to the branch which is pointed by a branch name, then basically this pointer is moved. And this is exactly what happened. The cleanup here shows now to a new commit. So far so good. Let's make also another change here, because I think we still could improve that a little bit. And of course, what we are all missing, which every project should have, is a readme file. The format you can choose. We will just now choose the RST format, the restructured text, because this is something we already know, and therefore we will just call it readme.rst file, and we are just creating that file. And of course, the file won't be very complicated. We are just making one section here with the name of the project, and we'll just write this as a toy project. Demonstrate the capabilities of Git with or in parallel development. I think that's more than enough. We are saving the file. Again, this is a new file, and now we added it. So in this for this toy project, that's already a big change. So let's basically put it into Git. Git status, of course, readme.rst is not part of Git, so we have to add it. So we are adding it with git add. Then now we see that it would be committed, and then we are saying check in, and we just say add the readme file. Okay. And this has been added. If you look at git slog, you see that yes, exactly here we have this. And you also see here that basically here we are on the cleanup branch. This is the head of the cleanup branch. So basically here the current head, the current pointer where we are, chose to the name cleanup, and his initial check-in, this is all this is associated with the name master. And again, if you look on the graphical client and we are reloading, you see that basically the name cleanup has been propagated to this new commit, which contains the new readme file, and so on and so on. We could basically develop the features in this cleanup branch. But now comes the point that somebody comes around, maybe because somebody found a bug in our project and in our originally published project, which is on master, and we would like to fix this bug without exposing the changes which we have made in this cleanup branch, because maybe we are not finished with the features yet. Or we would just go back to the state of master and try a different idea. For example, making an extension, a new feature which somebody requested or which we think it's important to implement. And therefore, what I would like to do here is just to, from here, go back to here and open a parallel development. Or if you go to the slides and to the figure at the beginning of the slides, we have basically now are in the process of creating feature 1, which we are developing it. We are somewhere here, and now I would like to go back to this original point and branch off a new development line. And this can be done very, very easily in Git. So basically, first we can look which branches we have, cleanup and master, and we're just going back to the point which is to the commit which is pointed by master. So we are saying git checkout master, and now we are on the branch master. You see that Git changed the content of the folder. I can see it here. readme.rst vanished because this did not exist in the master branch. At the commit, which is pointed by master, the file readme.rst was not present. And if you look at hello.py, it went back in the original very simple formulation. So basically, whatever we did in the cleanup branch is not visible now because I went back to the original point, which was pointed by the name master. And if you go to Spider, you see that also Spider has realized that. It says, for example, here readme.rst is unavailable. So basically, suddenly it vanished, of course, because Git deleted it because it's not part of the current commit. And of course, here also the hello.py automatically changed back to this original formulation as it was. Okay, and now I want to basically to open a new branch from that point. And I can say git branch, and I could give a new name, and I would call it extend, and then I would have to check it out. And these two steps, creating a branch and checking out, you can simplify if you just make a check out and you say -b and then a branch name, and that means, okay, from the current point, branch off a new development line. And you see it says, okay, switch to a new branch extend. Where does this branch come from? First of all, I can check, whether this branch exists. Indeed, I have also branch extend now, and I'm already on this branch of the development. And if I am just going to the here to the graphical Git client, I'm just reloading things, then you see that indeed the new name extend has been invented here, created, and this is exactly has on the same space or the same state as master. So basically it points to the same commit, and because it's bold here, this means I'm on the extend branch now. And let's basically just make an extension to our tool here. So basically what I will do, I will just now work on this file and just extending it. And I don't see anything which I have cleaned up, but that's so far. Here I just quick and dirty, I just would like to make an extension. Here it would be a very trivial one, of course. I'm just adding, just changing the message here. Here the message which the program prints, and then I'm changing to Git. I see that indeed hello.py has been changed. With add-u, I'm adding everything which has been changed to the stage, and then with CI, I'm just saying that I'm extending the greeting. For extend, usually you are using imperative. Here, if you are writing Git messages, extend the greeting. Okay, and indeed this has been added, extend the greeting, and if you make it log, you see only the history from this point on backwards. You don't see the things on the other branches. If you do git slog, this is here a little bit different. Git slog would show you the entire tree and also the branches, and you see here there is a branching point, a parallel development line. But the best thing is what you can do in that case is to go to the graphical client, because this shows you very nicely. We had here started at master. We have here one branch which contains this and these two commits. This is the cleanup branch, and here we have the other branch which is containing this one commit, where we extended the greeting. The way it's shown here and also in the git log and slog is that basically they are time ordered. So basically on this branch you have these commits earlier than the commit on this branch because they were submitted or committed earlier in time, checked in earlier in time. Okay, and that's it. We have now two different here parallel lines of development. Let's just make one more change on this extend branch, and the other change would be also very trivial. We just make our greeting a little bit more polite by letting it the greeter more polite by letting it ask how you are doing. How are you doing? So not a very important change, but for our toy project it should be enough. And then basically what I want to do is again add it and commit it, and the commit message would be something like make greeter even more polite. Okay, I made a mistake. The space is missing here, as you see, but no, it has worked. If I'm making git slog, you see that here I have also two commits on this branch and two commits on this branch. And on the best thing you can see is if you do the graphical client, and then you see I have two commits in the extend branch and two commits on the cleanup branch. So basically what I have achieved so far, if you are looking at this figure, that I have the master branch, I have one feature branch where I implemented something, and I have a second feature branch where I implemented something. But if I check out master, none of those changes are visible. And now basically what we are trying to achieve now is to import those changes which we have made in the parallel branches into the master branch, because usually the master branch is the branch which we think about that like the branch which contains the stable version of our project, so the version which I'm willing to give away to distribute. And basically now we think those changes are mature enough, so we want to integrate those changes into the master branch. And this is exactly the next thing we would like to do. So basically, if you're following the slides, we have now developed things on here slide 8 was basically developing on branch extend that we have done, and now we want to merge changes from the first branch to the main project. So we want to go back to the cleanup branch, and we want to merge first the cleanup branch. The order how we merge branches is up to us. It doesn't matter. I mean, it's usually dictated by the project and how the project is developed, and when a certain branch is mature enough to be merged. But in order to be compatible with the slides, I would like to do and merge the cleanup branch first. And because later I would like to show you something, an alternative way here on the merging, I will just make a copy of my hello folder, and I will call it hello.before merge. Okay. And because I want to copy the entire folder, inclusive with the subfolders, including the .git subfolder, which is very interesting, very important here. I am just specifying the -a option. Okay, and then we can have a look at hello.before merge later, which was created at that point of the history. But let's go back to the project hello, and basically let's go back to the master branch. So. And now I'm on the master branch. That means if you look at here and reload it, you see that I have two branches still, but my actual point is this master branch. And what I would like now is to integrate all the changes which have been done on the cleanup branch into the master branch. So basically I will merge it, and with Git terminology, I will merge this branch, the cleanup branch, into the master branch. So basically, I'm on the master branch, very important. So you should be on the branch where you want to apply the changes, and then you say git merge, and you are specifying from where you want to take the changes. And I want to take the changes, all the changes which are on the cleanup branch. That means if you are looking at here, that means I want the program to make sure that this commit and this commit, the change from this commit and the change from this commit is applied here on the status as we have it on master. And let's see what happens. And basically something has been done. And here, if you look at the messages, it says it was doing a so-called fast forward. And what you see is that there was something done with the README file. That's quite good, because in this branch, the cleanup branch, I was creating a README file. So apparently this has been added, and it was touching the hello.py file, which is quite good because, of course, in this branch we were changing the hello.py file. Now let's have a look what we have, how our project looks like. And now if you look at Spider, you see that again this readme.rst is here basically appeared. So again with the content which we have on the cleanup branch, and indeed also the hello.py has exactly the content as it had when we left it on the cleanup branch. Let's have a look on the graphical visualization. How does basically my Git history looks now? And if you reload it, you see that nothing happened. Just basically the master, the pointer, which was indicating the point, the end of the master branch, but just basically forwarded in time to be the same as the cleanup branch. Why did that work? Because basically you can just by moving in time forward reach from this point, from the initial check-in, the point to where the cleanup branch has shown. So basically that was successful, and this is exactly what is called a fast forward. I'm just shifting the pointer in time forwards because there's nothing complicated. Basically there's a linear history of time between this point and this point, right? You can just go this way. Okay. Now, because master is already showing on that commit, basically the name cleanup I don't need anymore, because I invoked whatever was on cleanup, whatever was in the history of the commit which is pointed by cleanup. I'm invoked that into the master branch. So basically I can just delete the cleanup branch -d cleanup, and it only deletes the name. So the branches are just pointers, and basically if you delete the branch, it only means that you are deleting that pointer which shows here in commit, but it doesn't matter because master still shows to there. Okay. Good. Now we would like to import the changes which are on the extend branch and into the master branch again. So this is my master branch. And now I want to import the changes from here. And it's clear that that will not be able to be done, that cannot be done by fast forward. Why? Because I am here on the master branch, and basically those changes cannot be directly reached from here just by going forwards in time. Actually, it's much more complicated. I have to go backwards in time and then forwards in time to reach those changes. So basically, I have to do something more complicated in order to incorporate those changes. But the nice thing is Git can do that automatically for me. So basically, Git can just take the changes which were done here and apply to the state of my project on here. So basically, when I'm merging extend, what Git will do is look what changed between this point and this point. So what are the changes between here and here, and all those changes will be applied to the point here. So let's do that. We just tried. So we are just to make sure on which branch we are. We are on the master branch, and now we are saying git merge extend. That means take all the changes from the extend branch which are not on the master branch yet and incorporate those changes. And it indeed started to do something. You can also see it says auto merging hello.py. As you remember, in the extend branch we only changed the hello.py file, so that's the only file. But then it says something about a conflict and what happened. So let's have a look what happened with this hello.py file. And if you load that's look horrible. You have here a kind of marker, here a kind of special marker, and here at the end a kind of special marker. So it's definitely not valid Python anymore. So what happened? The problem was that in both branches we were basically editing the same line of the hello.py file. And if you edit the same line, then those changes are concurrent changes, and Git doesn't know which one of the changes to apply. And therefore what Git does is to say, okay, I have concurrent changes. I don't know what to do with that, but you have to fix it manually. You have to decide which combination of the two changes you want to have at the end. And it shows you what is the version which you have in your current branch, which was on the master branch in that point, and the changes, the concurrent changes, the conflicting changes on the branch which you try to merge. And you see, okay, originally we just had one line, print hello, but in one branch we was wrapping it into the function. In the other branch we were just extending it. So what is the solution? Of course, we have to take the extensions. I want to take the extended greeting, but I want to keep the wrapped form. So I'm just here applying and putting it into the wrapper. And this is a change which Git can impossibly make automatically, right? Therefore, it asks you for help, and you have to do it manually in a way just to make sure that basically everything makes sense and your program is still running correctly. So we are combining the two changes, and we are now satisfied from the project. So we would like to tell Git that everything is fine now. If you make a git status, you see that there are unmerged paths. So basically that was the problem, which was the file which was modified in both versions. And we have to tell Git that no, the version which is no in our working directory is the correct one. So we are just saying git add hello.py. With git add, during a merge, we tell Git, no, the file is fine. You can put it on the stage. It can be committed. And then you say, okay, we are here, no, it's modified, this will be committed, and it also tells you all conflicts fixed, so there are no more file with constant, but we are still merging, and it also says you have to make git commit to conclude the merge. So let's make git commit, and if you make git commit, Git automatically gives you a commit message because you are merging, and this is a so-called merge commit, and then usually the usual termination is a merge branch extend. I think we can just leave with that. That's exactly what we did. And we have merged that. If you make git status, there are no changes, and we are on branch master. If we are making git slog, then we see that something strange happened here. Basically, the two branches which were spun off from here are together on master, and the best thing you can do here again is look on the graphical representation, and you see here what happened. I had two branches, the clean up branch and here the extend branch, and basically in the current point If I am on master, I have both changes, the changes from this branch and the changes from this one, because they are connected. If you mean, always if they are connected, it means that that basically the commit which is above them contains the changes from both of them. The nice thing is Git doesn't only apply the changes, but also makes sure that it remembers what kind of changes it applied, and therefore basically all these old commits don't get lost, but they are remaining in the history. So always, if you want, you can go back to any of them. So it's still the same, that whenever you made a Git commit, this commit stays in the database, in the history of your project forever. But of course, here the master contains all the changes together. The name extend we don't need anymore because we have merged the branch. So let's just delete it. Git branch -d extend, and if you look it up, it indeed vanished. Okay, and with that we basically covered the first part of the session, which I wanted to show you. If you look at the slide, basically this was the figure which we tried to implement step by step, having a branch, a master branch, spinning off to feature branches, implementing changes into the feature branches, incorporating those changes from these feature branches onto the master branch. So this is basically what we have done. There is only one thing I would like to show you, an alternative way to the fast forward which we had here. If you remember here, if you remember here when we were merging master, cleanup into master, that was the point here. Master was here, cleanup was here. We was merging master to cleanup. There was a fast forward, just because it could be linearly reached in time. And then when we merged extend, it was more complicated. There was a conflict. It was not linear in time anymore. There was a merge commit. And even here you can force, if you want, to make a Git to make a merge commit. The nice thing on that is that basically you can you always have a very well-defined commit which incorporates all the changes from a given branch into your main branch. And if you don't like it, you can just delete or revert that change, and then you basically get out everything from that branch from your master. And this is basically you can do by specifying a special option, the so-called no FF option, which means telling it that it should not do fast forward, not even if it's possible. And this is basically the last thing I would like to show you. I would like to tell you that basically this fast forward versus non-fast forward, there are different approaches, and different projects prefer different strategy, right? If you make fast forward, it's always nice because you don't have commits, you don't have loops in your history. Then history is quite linear. Some other projects don't care or like explicit commit merge commits in order to make sure that you can easily see where the changes from a feature branch entered the master branch, and that you can easily remove and revert it. Nevertheless, I would like to show you therefore this -no FF option, and now we go back to the point which we saved. So I will just go back to the hello.before merge version of my project, which I have saved here. I will just here close this graphical window because we have to open it again in the new folder. So just to remind us, where are we? Here we are exactly at the point, and where here we have the master and the extend branch, and let us see. We are on the extend branch. Let's also check out the cleanup branch. Here, let's look. If I update it, then it should also, the cleanup branch also here appears. So this is a situation master, cleanup, and extend. And now I want to merge cleanup into master. So therefore, as before, I'm just changing to master, and then git merge cleanup. However, now I'm just using as an option to the here to the merge, saying no FF. That means no fast forward allowed. No problem. Git can do that, and then it will make an extra commit for the merge with the usual commit message merge branch cleanup, and then let's just accept that. And now if you look at the graphical representation, you see that here I have if you look here, I have here on the master branch, I have the parallel development of cleanup, which has been merged into the master. So there's no fast forward, but this always is here clear that it was a separate branch which was merged at that point. Even despite the fact that fast forward would have been possible, Git didn't do that but merged it directly. And then basically now if we merge extend, of course this will then the story would be exactly the same as before. So if I'm just check out the master, I'm already on master. Let's delete the cleanup. I don't need the cleanup anymore because because it has been merged to master. And now git merge. Let's merge extend, the extend branch, which I can do. Of course, I get the same conflicts as before. Of course, I mean, nothing changed. My project is still the same. So basically, if you, no, I'm in the wrong folder. This is why it doesn't show it, because of course, it's still looking at the old folder, but we could just also fix it in leafpad in a second. Hello compile. You have exactly the same kind of markers as before, and the resolution of the conflict would be the same as before, because of course the branch did not change. The branches are still the same. The only difference is that I merged with an explicit merge commit. So I'm just solve the conflict. I'm just telling it that the conflict has been solved, and then changes to be exactly committed. So basically it's on the stage, and I have to use git commit to finish the merge, which I can do. So I'm saying just git commit, and then I get the usual commit message merge branch extend, which is a good one. I'm just accepting it, and that's it. And now if I'm looking here at the history, I see that basically it's a little bit more explicit. So basically you can see that here it was the initial check-in. Then basically this green is the master branch here up to this point here on the master branch, and it was another branch which has been merged, and then again there was a parallel development which has been merged. And okay, of course git branch -d extend can be used to here to remove the pointer to extend, because that has been already merged as well. And then the git history looks a little bit different. Which one you prefer is up to you, and especially up to the project which you are working at. So basically, just we will see on the next session. There are many different workflows. If you are working with others together, just accept the one which the project already has, or if you are large, if you are basically starting your project, decide for a workflow, document it, and basically just do things according to that. Okay. Thanks a lot for your attention for this session, and hope to see you in the next one, where we will cover how multiple developers can work on one project with the help of Git. See you there. Ciao.